Okay, good morning. The topic that I'm going to discuss today is hypothesis testing. So, again, what is hypothesis? It is an educated guess or a wise guess. A statistical hypothesis is an assertion or conjecture concerning one or more populations. This assertion may or may not be true. And the best way to determine whether a statistical hypothesis is true is to examine the entire population. Hypothesis testing is a set of procedures that culminates in either the rejection or non-rejection of the null hypothesis. The decision to reject or not to reject the hypothesis is based on the probability of occurrence of the sample results if the null hypothesis was true. So, these are the steps in hypothesis testing. First is to identify the problem. Second is to state the hypothesis. We have two. We have the null hypothesis and the alternative hypothesis. Choose the level of significance. Select the appropriate test statistic and establish the critical region. Collect the data and compute the value of the test statistic from the sample data. Then make the decision. Reject the null hypothesis if the value of the test statistic belongs in the critical region. Otherwise, fail to reject the null hypothesis. Then draw conclusion about the population. Okay, so I've been talking about critical values. In our normal curve, okay, so we have here, let us say, we have here our critical value or the tabular value. Okay? So in our normal curve, if this is our critical value, then this is our critical region or the rejection region. If the computed value falls in this region, then we have to reject the null hypothesis. If it falls in this region, this is the non-rejection region, then we fail to reject the null hypothesis. So there are two types of statistical hypotheses. As I have mentioned, we have the null and the alternative or alternate hypothesis. For the null hypothesis, it is the commonly accepted fact. It is the opposite of the alternate hypothesis, and the researchers work to reject, nullify, or disprove the null hypothesis. The researchers come up with an alternate or alternative hypothesis, one that they think explains a phenomenon. Okay, then work to reject the null hypothesis. The alternative hypothesis or HA or alternative hypothesis or alternate hypothesis, it is the operational statement of the theory that the investigator believes to be true and wishes to prove. This is the hypothesis that the sample observations are influenced by some non-random cause and is the contradiction of the null hypothesis. For our example problem, a researcher wanted to know whether the average sleeping hours of third-year engineering students is less than 6 hours. And the second one, the investigator wanted to know whether the prevalence of hypertension in Barangay Gulod Itaas is equal to that in Barangay Gulod Laba. So for this one, the null hypothesis is mu is equal to 6. And our HA is mu is less than 6. Okay? Then for this one, our null hypothesis is there is no significant difference between the prevalence of hypertension in Barangay Gulod Itaas and Barangay Gulod Labak. So it can be written as mu1 is equal to mu2. For our HA, we wanted to prove that there is a difference between the prevalence of hypertension in Barangay Gulod Itaas and Barangay Gulod Labak. So it will be mu1 is not equal to mu2. Okay. So, as you can see, there is a difference in our alternate hypothesis. Here, we already know where will be the direction or the location of our critical value. Okay, so it's on the left. While here, okay, we do not know if it's greater than or less than. So it can be here or here. So this one, this is a one-tailed test. And this one is a two-tailed test. Okay? So, next is the critical region or the rejection region. So, it is a set of values of the test statistic for which the null hypothesis will be rejected, and the acceptance region is the set of values of the test statistic for which the null hypothesis will not be rejected. The rejection and acceptance regions are separated by a critical value of the test statistic. So, we have here our one-tailed test. This is our critical region or the rejection region. And this is for our two-tailed test. This is our critical region or the rejection region. Okay? Next, for the test statistic, it is a value calculated from sample measurements and on which the statistical decision will be based. This involves specifying the statistic that will be used to assess the validity of the null hypothesis. For the decision rule, it is defined as a procedure that the researcher uses to decide whether to reject or not to reject the null hypothesis. Okay? So, there are two types of errors that can result from a decision rule. It can be type 1 or type 2 error. For the types of error, the type 1 error occurs when we reject a true null hypothesis. That is alpha. Type 2 error occurs when we don't reject a false null hypothesis. That is beta. Okay? Then, the power of a test. The quantity 1 minus beta is called the power of a test and represents the probability of rejecting the null hypothesis when in fact it is false. So, for the selection of the statistical tests, these are classified into parametric and nonparametric tests. For parametric test, it is based on assumptions concerning the parameters of the origin population. The validity of this test depends on whether the assumptions are satisfied or not. So the assumptions are the following. Samples are randomly selected from normally distributed population. So how do we test the normality of our distribution, of the normality of our data? So we can compute for its skewness, that it should be 0, okay? And also kurtosis, that is, it should be 0.265, okay? So another assumption is samples are selected in an independent manner except in the case of pale difference experiment. And when more than one population is sampled, variances are assumed equal. Okay? For the non-parametric or distribution-free test, it evolved and developed because of the rigidity of the assumptions of the parametric test, often assume no knowledge whatsoever about the distribution of the underlying population. When a researcher is in doubt of the validity of the parametric assumptions, the non-parametric tests are being applied. So the first parametric test that we are going to study is the t-test. The t-test is used to compare two means. The means of two independent samples or two groups, and the means of correlated samples before and after treatment. Ideally, the t-test is used when there are less than 30 samples, but some researchers use the t-test because, or even if there are more than 30 samples. Okay, so t-test for independent samples or groups. Okay, this is the formula that we are going to use. T is equal to x bar 1 minus x bar 2 over the square root of the sum of squares 1 plus sum of squares 2 over n1 plus n2 minus 2 times 1 over n1 plus 1 over n2. So how do we compute for the sum of squares? Sum of squares 1 is equal to the summation of x1 squared minus the summation of x1 squared over n1. Also for SS2. SS2 is equal to the summation of x2 squared minus the summation of x2 squared over n2. For our example problem, the following are the scores of 10 male and 10 female AB students in spelling. The test the null hypothesis that there is no significant difference between the performance of male and female AB students in the test. Use the t-test at 0.05 level of significance. This is our data set, or these are our scores for the male and female students. So for the problem statement, is there a significant difference between the performance of male and female students in spelling? For our hypothesis, the null hypothesis is there is no significant difference between the performance of male and female AB students in spelling. For our alternative hypothesis, there is a significant difference between the performance of male and female AB students in spelling. Or this can be expressed in terms of HO is mu1 is equal to mu2. And HA is mu1 is not equal to mu2. So this one is a two-tailed test. For the level of significance, we have their alpha at 0.05. For the degrees of freedom, we have n1 plus n2 minus 2. We have there 10 plus 10 minus 2, that is equal to 18. We subtracted 2 since we have two independent groups or independent samples. This tabular value, you can get this at your student's T distribution table. Okay? So for the statistics, we will be using t-test for two independent samples. So, for our computation, we need to get the summation of x1 squared, x bar 1, and n1. We also need the summation of x2 squared, x bar 2, and n2. So we have there 14 equals 14, 18, 17, 16, 4, 14, 12, 10, 9, 17. We have again 14, 18, 17, 16, 4, 14, 12, 10, 9, and 17. Okay? We have here 131. We have here 1891. This is 13.1 and this is 10. For group 2, we have there 12, 9, 11, 5, 10, 3, 7, 2, 6, 13. Okay, let me check. 12, 9, 11, 5, 10, 3, 7, 2, 6, 13. Okay? We have here 78, 738, 7.8, and 10. Okay? So next, let us compute for this sum of squares. So SS1 is equal to the summation of x1 squared minus summation of x1 squared over N1. So we have here 1891 minus 131 squared over 10. SS1 is equal to, we have 1891 minus 131 squared we have there 174.9. For SS2, we have the summation of x2 squared minus summation of x2 squared over N2. We have here 738 minus 78 squared over 10. SS2 is equal to 129.6. Okay? So, we have here t is equal to x bar 1 minus x bar 2 over the square root of SS1 plus SS2 over N1 plus N2 minus 2 times 1 over N1 plus 1 over N2. We have your x bar 1 is 13.1 minus x bar 2, 7.8 divided by the square root of, we have 174.9 plus 129.6 over 10 plus 10 minus 2 times 1 over 10 plus 1 over 10. Okay? So, our computed value of t is 2.88. Okay? Okay, so for the decision rule, if the computed value is greater than or beyond the t-tabular or critical value, reject the null hypothesis. Okay, so in our normal curve, our critical value or tabular value is 2.101. Okay, so this is our critical region. Our computed value is 2.88. So this will be, or this is our computed value. Okay? It belongs in the rejection region or the critical region. So for our conclusion, since the t computed value of 2.88 is greater than the tabular value of 2.101 at 0.05 level of significance with 18 degrees of freedom, the null hypothesis is rejected in favor of the research hypothesis. This means that there is a significant difference between the performance of the male and female AB students in spelling. Okay? Next. The t-test for correlated samples. So we have here t is equal to d bar over the square root of the summation of d squared minus summation of d squared over n times n minus 1. So here, d bar represents the mean difference between the pretest and the post-test. Summation of d squared is the sum of squares of the difference between the pretest and the post-test. So n is the sample size. For our example, an experimental study was conducted on the effect of the program materials in English on the performance of 20 selected college students. Before the program was implemented, the pretest was administered, and after 5 months, the same instrument was used to get the post-test result. So the following is the result of the experiment. Okay, you have there the pretest and post-test results. For the problem statement, is there a significant difference between the pretest and post-test on the use of program materials in English? For our hypothesis, we have there the null. There is no significant difference between the pretest and post-test results. And for our alternate or alternative hypothesis, the post-test result is higher than the pretest result. We want to prove that the program materials in English is effective. So for the level of significance, we have there alpha is equal to 0.05. Okay? So, for the degrees of freedom, we have there n-1 since we only used one group. That is equal to 19. T at 0.05, or the tabular value of T, is 1.729. As you have noticed here, we have there negative. Okay? Because for the computed value, if the computed value of T is negative, then this will also be negative. It will follow the value, the sign of our computed value. So for the statistics, we will be using t-test for correlated samples. So, for our computation, let us compute the difference. Okay? We have here, so negative 5, negative 5, negative 15, negative 10, 0, negative 10. We have here negative 4, negative 6, negative 5, 5. We have here negative 12, 5, negative 1, negative 5, 8, negative 5, negative 5, 0, negative 6, negative 5. So let us compute for the summation of D squared, D bar. Okay? So we have negative 5, negative 5, negative 15, negative 10, 0, negative 10, then negative 4, then negative 6, negative 5, 5, negative 12, 5, negative 1, negative 5, 8, negative 5, negative 5, 0, negative 6, negative 5. Okay? Again, let's check. We have there negative 5, negative 5, negative 15, negative 10, 0, negative 10, negative 4, negative 6, negative 5, 5, negative 12, 5, negative 1, negative 5, 8, negative 5, negative 5, 0, negative 6, and negative 5. Okay? We have here negative 81. For our summation of D squared, we have there 947. We have negative 4.05. Okay? So, T is equal to D bar over the square root of the summation of D squared minus summation of D squared over n times n minus 1. So, T is equal to our D bar, negative 4.05 over square root of 947 minus negative 81 squared over 20 times 20 minus 1. So, our computed value of T is we have there negative 4.05 over square root of, we have 947 minus negative 81 squared over 20 times 20 minus 1 is 19. We have there negative 3.17. Oh, sorry. 3.17. So for the decision rule, if the computed value is greater than or beyond the critical value, reject the null hypothesis. Okay? So, since our computed value of negative 3.7 is negative, the computed value is negative, so it will be located at the left. So, we have here our critical value or tabular value, that is 1.729 negative. This is our critical region. Our computed value is negative 3.17. So, it belongs where? in the critical or rejection region. So for our conclusion, the t-tabular value of negative 3.17 is beyond the t-critical value of negative 1.73 at 0.05 level of significance with 19 degrees of freedom. The null hypothesis is therefore rejected in favor of the research hypothesis. This means that the post-test result is higher than the pre-test result. It implies that the use of program materials in English is effective. Okay? So that's all. Keep safe, everyone.